If we label, as always, secant is the reciprocal of cosine. Cosine's x over r, so this is r over x. And now notice what's weird. I have never seen a triangle with these sides before. 2 radical 3, and then 3. At the very most, we've seen a radical 3 as part of the 30, 60, 90, but there's never been a whole 3. And we sure as heck haven't seen a 2 radical 3. So what's going on here? Well, if you think back to when we've done problems together at the end of class and we got an answer like this, let's say 1 over radical 2. Were we allowed to leave a radical 2 in the denominator? No, we had to multiply top and bottom by radical 2. So what do you notice happen? The problem changes. That's what's happened here. So I want you to think, what did we clearly multiply the top and bottom by? Can you see that we took some original problem and then multiplied top and bottom by radical 3? If this has been rationalized already, what was the original numerator? Well, the original numerator wouldn't have that radical 3 there. It would just be a 2. And that means the original denominator would have been a radical 3. So do you see how we actually had to rewrite this problem before we could do any math? Convince yourself that these two are the same. If I multiplied by radical 3 on the bottom, I would get 3. If I multiplied the top by the radical 3, I'd get negative 2 radical 3. And so you can see these are actually equivalent. But we need to work with this guy because it's familiar to us. So if secant is r over x, now we can actually proceed. So let's figure out what quadrants work. Well, that negative has to be with the bottom because r is always positive. So that means the x has to be negative, and x's are negative on the left side. Here and here. These are the two quadrants that work. Labeling, my x is negative radical 3, and the r is positive 2. That means I have a 30, 60, 90 with the missing side. Whoops, I put this in the wrong place. With the missing side being the 1. In this case, it's a positive 1, but on the right side, it's a negative 1. And my reference angle is across from the 1, so that means it's a 30-degree reference angle. Continuing, we're almost done. See if you can figure out the actual angles yourself. So I'm doing the math. And now I'm doing the math on the second guy. You should have got 150 and 210. Last step, let's convert these. So let's convert these to radians. Use your reference angle to help you begin. So since these are reference angles of 30, I know this will be 5 times 30, and I know that this is 7 times 30 because of 21. So my final answer is, for 150, that's 5, and 30 is pi over 6. And my second answer is 7 pi over 6. By the way, you can write 7 pi over 6 like this, and that means the same thing as 7 pi over 6, because if you put it over 1 and multiply, you'll get the same. So don't freak out about the way I wrote my answer. So let's try the last problem of the day. Cosine theta equals root 2 over 2. Labeling first always, x over r. But as we did before, we noticed that these sides are not familiar. Why don't you rewrite them yourself? So originally, it would have been 1 over radical 2. Because if I rationalize, I would get root 2 over 2, which is what the question wanted. So let's rewrite it like this, then write x over r. Now r is always positive, so that means my x has to be positive. So we're going to be in quadrants 1 and 4. Can you see why? Because they're both to the right. Drop the perpendicular. Let's label our sides. X is positive 1. R is radical 2. That means this is a 45, 45, 90 triangle. I'm labeling my reference angle as 45. Final steps. Let's give our final answer. The first angle is just 45 degrees. The second angle, I have to do some math. And when I'm in quadrant 4, do you remember what math we would do? Well, we're not going to use the 180 because that's for these quadrants. We'll use the 360. And 360, take away 45, leaves me with 315 for my second answer. Yeah. So our final answers in radians are pi over 4 and then 7 pi over 4. So G says find cosine where theta equals -1. As always, we'll label. Cosine is x over r. Since there's no denominator, let's put it over 1. And I want to think about this for a second. Look at r. R is equal to 1. So which triangle, 30, 60, 90, or 45, 45, 90, gives us an r equal to 1? If you said neither, that's correct, because it's either going to be a 2 or a radical 2 for our hypotenuse. So that means that this isn't a triangle at all. So in this case, when our r is equal to 1, rather than dealing with triangles, we have a special case of an axis angle. It's either going to be that our angle is 0 degrees, pi over 2, which is 90 degrees, pi, or 3 pi over 2, which is 270. So if r is equal to 1 in all of these cases, then we really need to focus on where x is -1. Look at all of these points. Which one is x -1? Well, x is -1 on the left side, so that means that we're going to be over here at 180, because there the point is -1, 0. X down here, if you're like, well, what about the other points? Well, down here, x is 0. And same with the 90 degrees. X would be 0 as well. And then over here on the right side, my x is +1. So the only place where x is -1 is right over here on the left. So we're done. We've already figured out our answer. Theta equals pi. That is the only spot, or you could say 180 degrees. This is the only angle where if I were to take x and r, divide them, I'll get an answer of -1. Let's try another one that's similar. Let's look at sine of theta equals 0. So again, sine is y over r. Putting this over 1, I see that since r is 1, it has to be an axis angle, one of these 4. Now we have to pay attention then to where y is equal to 0. So look at all 4 points, fill them in, pause the video, fill in the points. Where is y equal to 0? Hint, it's at more than one spot. So if you said at pi and at 0 degrees, you're correct, because in both cases, my y value is 0. Keep in mind, up here, y is equal to +1, and down here, y is equal to -1, because we're going up and down. So in this case, we have 2 answers. We have pi, or 180 degrees, and then we also have 0 degrees, or 0 radians. So my final answer then is theta equals 0 and 180 degrees, or 0 and pi radians. Okay, now I'm going to mix it up. I'm going to put 2 problems side by side, and let's see if you can do both. So the first problem will say sine theta equals -√2 over 2. And problem J says tangent theta equals 0. Pause the video here, try them yourself. So for the first problem, I'm recognizing that I'll need to rewrite this. We don't have a triangle with √2 and 2, so we'll rewrite it as 1 over radical 2. Don't forget the negative. Now we can put our formulas. So this would be y over r. So since r is always positive, that negative has to belong with the y, and we're looking for which two quadrants y is negative in. That would be everywhere below the axis. So quadrants 3 and quadrant 4. Y is -1, r is radical 2. And our x then would have to be a 1 because this would be a 45, 45, 90 triangle. So our final answers then are this big angle, which is 180 plus 45. That gives me 225 degrees. And then this large angle, which is 360 minus 45. And that's 315 degrees. Final step, let's convert to radians. So our answers are, if this is, remember, 1 pi over 4, 3 pi over 4, that's 5 pi over 4. And then in the fourth quadrant, we have 7 pi over 4. Check if you got that. If you didn't, take a moment and look back at where you made the mistake. Let's move on to J. Tangent theta equals 0, so tangent is y over x. Let's put this guy over 1. Now, notice that there is no triangle where we have a y or one of our sides being 0. So this has to be an axis angle. And we want to go where y is equal to 0 and x is +1. The only place that occurs is right over here. X is +1 because we're to the right, and y is 0, meaning we're on the axis. But I want to stop you there. There's actually one more point where a tangent can equal 0. See if you can find it. It's over here on the left side. Let's see why. The point here would be -1, 0. And notice that if you did y over x, you would get 0 over -1, which is still 0. So the key thing to remember here is that when you have something equaling 0, that x, especially for tangent, that x could be a +1 or it could have been a -1. In either case, you'll divide and get 0. So make a note to yourself that this could have been a plus or minus 1 in the denominator. Therefore, we have two answers. My first angle is pi, and my second angle is, well, we haven't opened up at all, so that would be 0 degrees. Or we could say 0 and 180 degrees. I hope that clarified. Sometimes we can deal with special right triangles, and sometimes when we have these weird sides, we have to deal with quadrant angles or axis angles. You know you have an axis angle when your sides include 0 or 1. Or sometimes, we might see this tomorrow, undefined. You know you have a special right triangle when your sides are 1, radical 3, 2, or radical 2 in the case of 45, 45, 90. And we're done.